So solving this inequality, we can times up on both sides by 0.2 root n. If we times up by root n on both sides is useful. So we've got, or rather we can bring it up on this side. So we've got 1.645, so less than or equal to. And then I can go term-wise on each of these things. So I have 15 root n minus 2.326 times, and then this is root n over root n. So that's going to cancel. Times 0.2, and then this is minus 0.49 root n all over 0.2. This is going to tidy up nicely then to give us 0.5, because we've got 0.1 divided by 0.2, which is 0.1 times 5, which is 0.5, root n minus 2.326 is greater than or equals. Again, the greater than or equal to sign doesn't mean anything because we're working with continuous distributions. I just keep putting it in there out of habit. Don't worry about that because it makes absolutely no difference. It's just as valid as without the thing there. But I think the question normally won't put it there because it's extra writing. Okay, so we clearly need square root of n to be greater than 1.645 plus 2.326, and then this whole thing times 2. So, and then we can square things on both sides, which is a fine function because we're dealing with n is strictly positive, right? And the square of a positive number is always like whether we have to change the sign of an inequality when we do a function to each side depends on the shape of that function. You can Google that if you like, but because n is positive, we can square both sides of this thing and we don't have to change the sign of the equality. So specifically, this tells us that 4 times, what's this, 3.971 squared must be less than n. And then this is going to give me, eventually this is going to lead to n being greater than 63.1. So you can type that into a calculator and it should give you that. N must be greater than this. So the smallest n we can have is 64. So again, there's a lot of logic to that question. It's harder to sort of go through this because it's a difficult thing, and I haven't done a hypothesis test for a very long time. But the premise is we're just matching areas onto a thing. We're thinking about what area on one graph will cause us to have a type 1 error or a type 2 error, and what does that correspond to on a separate graph. And then we're just solving inequalities. And I've taken a long time to do this question, but I think if you work through this by yourself and if you see other questions like this, this is a question you can do in certainly less than 6 minutes. So